All right, hello everyone. Thanks for sticking around for part 2 of this tutorial on proportionality-based fairness in social choice. This is going to be about participatory budgeting and other applications of this proportionality idea. Quick recap of what we heard in part 1. We looked at apportionment, a very simple case of proportional representation, and then at multi-winner voting, where the goal was to elect K out of M candidates. We had a look at proportionality axioms that came in various types. Some of them were guarantees for cohesive groups. So if we have a group of voters that have similar preferences, then these axioms said that at least a certain number of the candidates in the committee should come from the preferences of those groups. Then we saw priceability, which is a formalization of the idea that everyone should have equal voting power, where we have a currency that we split equally, and then voters can use it to further their preferences. And we briefly saw the core, which can be seen as a guarantee for all groups, not necessarily cohesive ones. And then we had a look at some voting methods that turn out to be good recipes for all kinds of social choice scenarios, not just multi-winner voting, including proportional approval voting with its special objective function, sequential fragments rule, and in this part we will see a third rule, the method of equal shares, that we've proposed recently, and that is also quite flexible in its use. Okay, and so in this part 2, I'm mainly going to talk about participatory budgeting, and then we'll go very briefly through a couple of other scenarios where proportionality is a useful and promising idea. Okay, so what is participatory budgeting? Most generally, it is the idea of a government letting its citizens have a say about how the government spends its money, and this idea emerged in the 1990s in Brazil, spread through South America, and that was done mostly through discussion, deliberation. So a neighborhood came together and discussed in some kind of town meeting how the budget should be spent. It was used on several levels, most prominently on the city level. And then it spread further to North America and Europe, where it took on a much more formal character. And so here's how participatory budgeting works in most places nowadays. The city government or the parliament designates a fixed budget for participatory budgeting, usually each year. And then residents are invited to submit project proposals. And these come with a description of what is to be done and how much money it would cost. City officials then decide for all of those proposals if they are in scope. They might suggest changes or merge similar proposals or shortlist projects. Then in the fourth stage, this is the one that we are going to be very interested in, is that residents vote over those projects. Usually they're giving some instruction like, please vote for your 10 favorite projects. Nowadays, this is often done using online interfaces. And then once the vote is done, we now need to decide what are the winning projects. And the most common way of doing that is to greedily take the projects with the highest score, that is the highest number of votes, until the budget runs out. And then in the following year, city officials oversee the implementation of the winning projects. Here I've written a short list of some example cities that use participatory budgeting and some of the things that make them special. The largest ones are Paris and Madrid, who in years past spent 100 million euros per year using participatory budgeting. In the Spanish cities, knapsack votes are particularly popular. That means that voters can vote for as many projects as they like, as long as the projects they vote for in total cost at most the overall budget. And politicians tend to like that idea because it means that voters have to internalize the budget constraint that the city faces. But most other places use things like Paris, asking people to vote for up to 4 projects, or up to 5 projects, or in Lyon up to 10 projects. But there are many other ideas also. So some cities ask their voters to distribute 10 points across projects. And so this is mostly how these implementations differ. Everyone has their own idea of how exactly voters are going to vote. But once the vote is done, we just have the scores for each project, the number of votes they got, and then we sort and go greedily and fund the projects that we can. Another thing worth noting is that we have quite a lot of Polish flags here. This is not just because my co-author here is Polish, but also because Poland has a law requiring all of their large cities to use participatory budgeting to spend at least 0.5% of the city budget, and this has been around for several years. So all kinds of cities, like more than 50 cities in Poland, have been using this for roughly 10 years. And so most of participatory budgeting really happens in Poland. Another thing to briefly mention is that there's a website called Pabulib, the Participatory Budgeting Library, where we have full vote data from several cities. That means for each voter, we know exactly the projects they voted for. And so we can use this data to simulate what would happen if the cities had used a different voting method, because spoiler, I do not like the current voting method that most cities use. Okay, so let's look at the basic model. This is not a surprise given what we've seen in part one. We have a set of voters, we have a set of projects. Each project comes with a fixed cost. And then for a subset of the projects, the cost of that subset is just the sum of the cost. The city imposes a budget limit, then an outcome is just a subset of projects that can be afforded within the budget limit. And then for simplicity, because most cities do that, I'm assuming that each voter submits an approval ballot that is a set of projects that the voter approves. But this model could be enriched in various ways, for example, by adding feasibility constraints or going from approval to other utilities, additive ones, non-additive ones. We could even allow for negative utilities. An important special case of this model is when each candidate costs exactly 1. That is the unit cost case. And this shows that the committee elections model is a subset special case of the participatory budgeting model. So everything I say here can be used for committee elections, but I'm mostly using this connection the other way, looking at things we've done in committee elections and trying to generalize them to the knapsack constraint. Okay, so here's an example of an approval ballot with some example projects. So this is what a voter might face. Okay, so let me briefly motivate why we might be interested in a proportional vote method rather than the simple vote method that cities use nowadays. Here's a fictional city called Circleville. It has 4 districts: north side, east side, south side, and west side. They all have roughly similar populations, but north side is slightly the biggest with 120,000 people living there. And now assume that each voter in north side votes for all the projects in north side and for none of the projects outside north side. And all the other people do similarly. They are only interested in projects from their own district. Then we can write down all the projects and sort them by the number of votes. And then we take the most popular projects, like cities do nowadays, and declare them as winning. And in this case, this would mean we take project A and project B, which together cost $400,000, which is the overall budget, and the rule terminates. Well, but that seems like a terrible outcome because we have spent 100% of the budget in north side, despite only a bit more than a quarter of the people being from north side. So this is a very unproportional outcome, and we might want to have the funding be spent proportional, that is all over the city, for example. Now, the way most cities handle this problem is that they, before the vote even starts, split the city into different districts, decide how much money is to be spent in each district, and then let voters from each district only vote for projects in their own district. But I think that's not a particularly great solution for many reasons. For example, you cannot vote for things in other districts, even if you care about them. So for example, A here might be constructing a playground in a public park, and there might be parents from all across the city that want to vote for it, but they can't if they live in the wrong district. It could also be that some districts just don't have particularly good projects proposed, but they will be funded even though no one really likes them because the budget is fixed from the start. But we can use a proportional rule to do this division naturally and have equal spending across the city and across voters. And how would I propose such a proportional rule to look? We have introduced the method of equal shares as a simple and polynomial time method that enjoys strong proportionality properties. And on a very high level, I'm going to give an example in the next slides. It works as follows. We take the budget that the city has and we split it equally between the voters. So each voter gets allocated the same size slice of the budget, not to do what they want with it, but we just virtually allocate it to them. And then we look for a project whose approvers can pay for it. So we look at each project, we sum up the amount of money that its approvers have, and if that's enough, we might selected as a winner. So we buy such a project, and then what we are going to do is we're going to share the cost equally between its approvers. Or in case that's not possible, we do it as equally as possible in the sense of minimizing the maximum payment of anyone for that project. And if there are several options, several projects that are affordable in this way, we take the one where we can spread the cost most thinly, most evenly. Now, I'm excited to say that a rule like this, the method of equal shares, has been used earlier this year in April in Wieliczka, a small town in Poland, for their Green Million participatory budget, and I think it was a great success. And a small city of Aarau in Switzerland is right now, as we speak, voting, and they are going to use the method of equal shares to decide the winners of the election. Okay, so let's go through a little example. Let's take a budget of $100. We have 10 voters, and so splitting the cost equally, everyone is going to start with $10 of virtual budget share. We have 5 projects here with their cost as indicated, and 1 means that the voter voted for the project, 0 doesn't, and equal share will, as it turns out, select project 3, then select project 5, and then terminate. Let me explain why. So let's look at project 1 first. Project 1 costs $35 and has these 5 supporters. So if we split its cost equally among the supporters, then each of them has to pay $7. And so the maximum payment is $7. But now there's another project 2, which costs the same thing, but it has more approvers, 6 instead of 5. And so we can spread this cost more thinly so that the maximum payment here is $5.80. So in that sense, the method of equal shares would prefer to buy project 2 rather than project 1. But now let's have a look at project 3. Project 3 costs less than project 1, but it has the same number of approvers. And if we divide 25 by the 5 approvers, each of them has to pay $5. And that's the smallest number we've seen. It's smaller than the 580 here, and it's also smaller than what we get for projects 4 and 5. And so project 3 is going to be implemented so that the first 5 voters, not 6, the first 5 voters each spend $5. So they have 5 left for the remaining rounds, and the other 5 voters have 10 left. Okay. And so now it turns out that projects 1 and 2 are not affordable anymore. Its supporters do not have enough money to pay for it. However, we can look at projects 4 and 5 and compare those. We have project 4 with cost $24. And if we try to spread it as evenly among its 4 supporters as possible, we see we can't do it completely evenly because that would be having everyone spend $6, but some of the supporters do not have $6 anymore, so they can only spend $5, but do some kind of water filling, leading to the maximum payment being $7. Project 5, however, has the same number of supporters, also 4. It has the same cost, but its supporters are richer. And richer is better according to the method of equal shares, because now we can spread the cost with a maximum payment of 6. And so project 5 is going to be preferred. Now, why does it make sense to say that a project with richer supporters is better? Well, because rich in this setting means that we haven't been able to make you happy in previous rounds. And so therefore you're currently unhappy, you deserve happiness. And so it's good if we can find a project to make people happy that haven't been made happy before. Okay, so now project 5 is selected, and then one can check that none of the other projects can now be afforded using the budget shares of the people voting for it. Now, but projects 3 and 5 together only cost $49 when we had $100 available. And the unselected projects 1, 2, and 4 were unaffordable in one sense, namely that its supporters did not have enough money to buy them, but they are still affordable in the objective sense that there is enough money to pay for them. And so we can say that equal shares is not exhaustive because it might not select a set that exhausts the budget. And the intuition is that equal shares only spends money if fairness forces it to. If some voters are unhappy enough and are cohesive enough that they can together buy projects. Now, maybe a city is happy that it doesn't have to spend so much money, but presumably they wanted to spend the money allocated to participatory budgeting. So there are several ways in which they could complete the outcome. For example, they could say, okay, we have $51 left. We have some other priorities, and we're going to use them to further those, for example, by completing using the utilitarian method. Our main proposal, though, is to complete by varying the budget, which means is that we're going to run the rule again, but this time with a budget of $101 to start, and then $102, and so on, all the way until the output is infeasible with respect to the real budget. And then we go one step back, and that's our official result, and that will spend a good part of the budget. And no matter how we complete equal shares, it satisfies extended justified representation, EJR, the property that we saw in part 1. And let me define it again for you, but this time in a generalized version that applies to the participatory budgeting case. So it says that for all groups of voters, all subsets of the voters, suppose they have a proposal. A proposal is a subset of projects that the group of voters can afford, which means that the cost of that proposal is at most the budget times the fractional size of that group. So for example, if we have 40% of voters in group S, then cost T can be at most 40% of the budget, and such that S unanimously approves the set T, that is every project in T is approved by every member of S. Then at least one voter in S approves at least as many projects as are in T in the equal shares outcome. So writing UI for the utility in terms of the number of projects I approve in the outcome, it must be that for at least one voter I in S, the utility they get from the actual outcome needs to be at least the utility they would get from T. Okay, so this is for participatory budgeting, the only natural method that we know that satisfies EJR. I won't go through the proof, but roughly the idea is that the projects in such a proposal set T offer pretty good bang per buck because there are enough voters liking it, and equal shares always selects projects with the best bang per buck, and so it will use the money of the coalition as well in some sense, and therefore at least one of the voters will approve quite a lot of projects. Okay, so of course we have, as I said before, we can apply any participatory budgeting rule for the special case of committee elections with the unit cost assumption, and thus we can compare it in the multi-winner committee selection frame of mind to the rules we've seen before. So here's a table with the different rules and different axioms. In part 1, we've seen PAV and sequential fragment, and now we also have equal shares. Equal shares, generally speaking, is somewhat similar to sequential fragment. So for example, both of them are priceable, but it does get EJR, which sequential fragment fails. PAV, as we've heard, is an approximation to the core. In fact, it's an optimal approximation to the core subject to satisfying this Pico-Dalton property here. Equal shares also gives a much worse approximation to the core. But compared to PAV, it has the nice advantage of being definitely polynomial time computable. And it extends to participatory budgeting quite well. And by quite well, I mean that it works even for utilities which we might want to use in PB, not just approvals. Sequential fragment, though, can also be used for PB. The definition makes just as much sense. You fill up people's bank account until some project has supporters with enough money to pay for it. PAV you can also use for PB. Formally, you just maximize the objective function of PAV over the set of all feasible knapsacks, but this will violate proportionality very, very much, so it will not approximate even EJR. So the proportionality properties of PAV really only apply in the unit cost setting, not for PB. Okay, so I mentioned that method of equal shares can also be used for utilities, not just approvals. So by that I mean that each voter is going to have a utility number, a non-negative utility number that they assign to each project. And then we assume that their utility for a bundle of projects for the winning set is just the sum of the utility numbers for the individual winning projects. So this is a generalization of what we've seen before. Before, we've essentially assumed that UIC equals 1 if I approve the project and 0 otherwise. Now, the idea of the generalization of equal shares to additive utilities is that voters are going to contribute to the cost of a project not equally as before, but in proportion to their utility. So if I have utility 2 for a project and you have utility 1 for the project, then I'm going to be asked to pay twice as much as you for the project. And so this can be formalized, and then equal shares repeatedly takes a project with the smallest row, which is a kind of bang per buck measure, and takes the best available project. And if we do this, then we can generalize EJR for the case of additive utilities rather than just approvals. I'm not going to give you the definition in detail here because it's a bit complicated, but equal shares run like this does satisfy EJR even for those additive valuations, but only up to one project. By which I mean that we might have to add an extra project to satisfy EJR. Now, it's a bit sad that we can't get like full EJR. We have a nice excuse, which is that getting an EJR outcome is weakly hard for additive utilities. The reason is that in case there's only one voter, then to satisfy EJR, we must select an outcome that maximizes the utility of that voter. And that's the knapsack problem, which is weakly NP hard. And now method of equal shares is not pseudo-polynomial, but really polynomial, and so therefore it cannot satisfy full-on EJR, but EJR up to one project is pretty close. That said, EJR does exist. We have an existence proof, but this does not imply a sensible voting rule. Okay, so how can we use this feature that equal shares can be used for general additive utilities? Well, it means that it can be used by cities that would like to give voters, say, 10 points to spread across projects, rather than just be able to do an approval vote. And in fact, Aarau, which is using equal shares as we speak, is doing that. So their voting method is if everyone gets 10 points and they can spread it across projects, provided they give at least 3 different projects at least 1 point. But even for cities that want to use approval voting, it can be nice to move away from the 0-1 utility interpretation of these approvals. Why? Because if we run equal shares in this, as I've explained it to you, then it will select projects, roughly speaking, in order of the number of votes divided by their cost. So some kind of efficiency notion, votes divided by cost. But if you remember, the voting rule that cities actually want to use, or actually use in practice, does not go in order of number of votes divided by cost, but they just go by the number of votes. And so if they were to switch over to equal shares in the 0-1 interpretation, the outcomes would change quite dramatically, in particular in favor of small, cheap projects rather than larger, expensive projects. And that might be a good thing, but it might also be a bad thing, especially if you hope that participatory budgeting gives you some sort of visible large projects in the outcome set. And so how to solve this problem is to use what we call cost utilities with equal shares. And that just means if I don't approve a project, my utility is going to be 0 for the project. If I do approve it, my utility is not 1, but the cost of that project. And so now equal shares will go in order of number of votes times cost divided by cost, which means it goes in order of number of votes. Now, it turns out that this rule, equal shares with cost utilities, has a simple explanation. And it's actually our, I'm sorry, I hope you can't hear the cars too much. It's actually our recommendation for cities to use equal shares of cost utilities, and one can simply explain it as follows. We repeatedly select the project with the highest number of votes, provided its supporters have enough money for it, and we split the cost equally among the supporters. And if at some point a voter runs out of money, or the money that was assigned to the voter was spent, then we delete the voter and update the vote count so that this voter does not count for future selections of projects with the highest number of votes. And there's a little asterisk, unfortunately, which says that if a voter is not down to 0, but to very little, then they count as a fractional vote. Okay, let me have a look at time. So as I said, on Parbulib, the participatory budgeting library, we have full voting data for lots of cities, including noticeably Warsaw, which is very large with hundreds of thousands of voters. And we can use this data to simulate what would happen if they were to switch from the actual outcome, the actual rule, which is the greedy rule, to equal shares. For example, we could look at what's the utilitarian welfare measured in terms of cost utilities for the two rules. Here we look at each district separately, and we see that equal shares does worse than the actual outcome, which is unsurprising because the actual outcome rule approximately optimizes this measure, but we do not lose out too much. So these numbers here is the average percentage of the spending that is approved by a voter. However, we can also ask what percent of voters have positive utility. That means what percent of the voters have at least one of the projects they voted for in the outcome. And here equal shares does noticeably better. With, for example, in this district here, it's doing very well with 94% of voters liking at least one project under equal shares, but only 80% under the actual outcome. And I'm not sure, but I think Warsaw allows you to either vote for 10 or even 15 projects in these elections. So if you vote for 10 different projects and get 0 of them as winners, that can be a bit disheartening to voters, and that actually does happen. I have seen in the data very big approval sets, all of which are losers. We can also ask what percent of voters prefer the equal share outcome over the actual outcome. So we compute their utility in both outcomes, and we ask what fraction prefer equal shares. And under the number utility measure, which is the number of selected projects that I like, equal shares wins dramatically. Why? Because it tends to select more projects, but smaller ones. But even under cost utilities, it's roughly around the 50% mark. So there's no decisive advantage of either rule. Okay, final bits of data. As I said, in Velička, the Green Million participatory budget was done in April. And here I've plotted the results on a map, because for each project we know where it is located. And I'm actually quite pleased. So notice that compared with these pictures here, I had the actual outcome on the left and then our simulation to the right of it. Here it's the other way around, because this time the simulation is actually the standard voting method and the truth is equal shares. One thing that immediately jumps out is that in this corner down here, there are a few very small villages of this region that got some projects funded, whereas they did not get any projects funded under the standard voting method. And the same is true for this corner of the city. And I can plot a kind of heat map where for every point on the map, I plot what is the distance to the closest winning project. And we see some very dark areas if the standard greedy voting method was used, but in fact they've used equal shares where everyone is reasonably close to at least one winning project. Okay, in the last part we had in the chat a brief discussion about strategy proofness. That is, can these rules be manipulated? Is it always in your best interest to vote exactly what you think, or can you sometimes strategize? Unfortunately, the answer is that you can strategize with these rules. In fact, there are known impossibility theorems that say all proportional rules must be manipulable. Here's the intuition. Suppose I vote for a project that is very popular. It's going to win anyways, but I vote for it. In which case, for example, equal shares will take some of my money to pay for that project. Then in later rounds, I have less money and I might run out of money pretty soon. Whereas if I don't vote for it, it still wins because it is popular, but I keep my money and can use it to get more projects later on. Okay, so we are hoping to convince more cities to use equal shares. There's a Wikipedia article about the rule, and there's equalshares.net, which tells you all about this rule. Okay, so let me briefly mention a few extensions in which research about participatory budgeting and voting participatory budgeting could go. One point is just understand voting data. So we've talked a lot about EJR, which has these cohesive groups of voters, but in actual voting data, there are not many very exciting groups of this kind. So is there other ways in which we can understand voting data, identify groups with similar interests? What is the right way to cluster voters and to analyze whether a particular voting outcome is good or bad on an actual data set? What about negative votes in a proportional setting? Negative votes make sense, for example, if something like a loud playground is supposed to be built right next to your house. Maybe you want to vote against it. How can we take this a proportional way? How can we add constraints? I think the most natural constraint is at most one of these constraints, where we have some empty plot of land, many projects that could be implemented there, but only one of them can. So how can we do that while still satisfying good axioms? But arbitrary constraints could be imposed, not just these, and then we go into the direction of judgment aggregation and being proportional in judgment aggregation. Participatory budgeting is often repeated every year, and we might want to use that somehow. So for example, if some group of voters is unhappy this year, maybe they should retain some voting power, and we should try to make them happy next year, and so ensure fairness over the long term. There has been a little bit of work, but not very much. We could look at multi-knapsack, so add several knapsack constraints simultaneously, such as money and time and CO2 emissions. Or we could use a money constraint, a knapsack constraint, plus also constrain the number of winning projects in total. Because in talking to some cities, we've heard that they do not like the prospect of suddenly having very many winning projects. Equal shares tends to select more winning projects than the normal greedy rule. And we can also look at agent contributions, where maybe some agents can privately top up the funds to make some projects that just about lose into winning projects. Okay, so I have time to talk about a few other settings, not participatory budgeting, in which proportionality has also been studied a little bit, and where more could be done. In general, you can define lots and lots of models and then try to find proportional axioms and voting rules for it. So one of these is multi-winner elections, but this time not with approval input, but with ranking input, where people rank their favorite candidate, second favorite candidate, and so on. Now for this, there is actually a rule, the single transferable vote, which is a proportional method, and it's an actual use in politics, for example, for Australia's Senate, in Ireland and Malta, and in many local elections, such as the parliaments of Australia's states. And here's an informal description. It sounds a little bit like equal shares, where we have a budget of K, which is the number of seats, and it will cost 1 unit to elect a candidate. And to start, we again split the budget equally between voters. So each of the N voters gets K over N as their starting budget. And now we repeatedly look for a candidate that can be purchased using the money of voters, but only the voters who rank it top. Okay, and so if in your ranking already, if your top choices have been elected, then we look at your sort of current top, so your favorite non-elected candidate. And if there is such a candidate, then we elect it, put them in a committee, and deduct the money in some way from the candidate supporters. However, if no such candidate exists, then we eliminate the worst candidate, the one with the fewest votes, eliminate them from the entire system, and then look again, because now maybe there's more agreement among the remaining among the voters for the remaining candidates. And now this voting rule satisfies a proportionality axiom that is somewhat similar to PJR and Friends. It's quite weak. It's called Proportionality for Solid Coalition, or PSC. It says that if you have a group of, say, 30% of the voters and they rank the same candidates on top, then 30% of the committee seats should be filled with those candidates that they agree on. There has been recent work to define new rules apart from the single transferable vote. These rules do not use this elimination step here, and thereby satisfy some stronger proportionality properties, including a property known as rank PJR, which is stronger than PSC, and they also satisfy better monotonicity properties, including a variant of the method of equal shares. In particular, I've told you about how it can be used with utilities. Well, you can convert rankings into utilities, particularly using a lexicographic scheme where you have 1 trillion utility for your top place alternative, then 1 million for the second one, and so on down. And that satisfies these nice properties. But as I say, more is to be done here. Particular, yes, this is stronger than PSC, but it's not clear that this is like as strong as we'd wanted. And there's a bunch of rules around, but we don't really know which of these is the best rule and why. And because this kind of rule, that is this output multi-winner and this input, is in actual use, it could be useful to have a more decisive recommendation of social choice theory. Okay, now let's consider sequential decision-making, another model. Here we have several rounds, say capital T rounds, and in each round there's a set of available alternatives, Cj, and in each round there could be a different set of alternatives, or the same, but usually it will differ. And in each round we have to make one decision, because we have to take one of these alternatives. We also have a set of voters, and the set of voters stays the same across rounds, and each voter says in each round which candidates they approve. So let's stick to approval voting, but we could also consider rankings or utilities in each step. And now our goal is to find a fair voting rule that makes these decisions in each round. We can require this rule to also be online, that is, to make a decision in the current round, it cannot look into the future, what will be the available alternatives then, and what will be the approval sets. It can only look at what's done so far and the current preferences. And then the setting is known as perpetual voting and has received some interesting work in recent years. What do I mean by fair? Here's the rough idea. If you have a group of alpha% of the voters, then this group should approve the decision in alpha% of the rounds. And you can define analogs of PJR and EJR with this idea. There are a few subtleties. In particular, you need these groups to have quite a bit of agreement. They need to be pretty cohesive. They need to agree in every round on at least one candidate that they all like together in order to get guarantees this good. Otherwise, you quite easily get two axioms that are not satisfiable. And such properties are again satisfied by analogs of the rules we've seen, the same cast of rules. Particular Fragment's rule is good because it is fully online. You don't need to look into the future to make decisions now. Equal shares is almost online. You can go round by round, but it does need to know from the start how many rounds there will be in total. It needs to know that in order to know exactly how much budget to give each voter at the very start. You can also use PAV. PAV gives you some stronger properties. However, it is completely offline. It needs to know everything from the very start. There's some other work on sequential decision-making and going in the direction of proportionality, often used focusing on maximizing so-called Nash welfare, which also tends to have proportionality properties, so this has not been formalized. Okay, here's another application, proportional rankings. So we've discussed the Alabama paradox and house monotonicity in part 1, which means that if the number of seats grows by 1, then no one should lose a seat. And this property can be applied to committee voting, which means that if I get my K committee of size K from a voting rule, and then I ask for a K plus 1 size committee, it's essentially the same committee I get except one extra candidate in it. And some rules are house monotone in this sense, in particular sequential Fragment, whereas others are not. PAV isn't, and equal shares isn't either. That means if we go up by one one slot, then they could change their mind about what they do with the rest of the committee also. But if we use something like fragment, it constructs the committee one by one, and therefore we can view its output as a ranking of the candidates, of all M candidates. And this ranking is proportional in the sense that each prefix of the ranking is a proportional committee. And so it proportionally reflects our input preferences. And doing this kind of thing has many applications. For example, aggregating search results, combining party lists. So you have different parties they want to join, and how do you list their candidates, listing topics in online deliberation platforms. So this kind of idea has been used in Liquid Feedback, which is a popular platform for liquid democracy deliberation in the Pirate Party in particular. And it's also been suggested in this paper here for vote systems for Q&A sessions. So you're listening to a talk. During the talk, you can, on your phone, write in a question. You can upvote other people's questions. And then you can use a proportional ranking rule to rank the questions. And the moderator can take the most popular questions. Usually this is done in the standard way, just by ranking the questions in order of vote count. But for example, say the speaker talks about 3 different topics. One of them is particularly popular. Then maybe all the questions, all the top questions come from the same topic. But if you use a proportional rule, it's more likely to be a mix of topics and interests represented across the ranking. Here's another one. This one is more continuous rather than discrete. This is given preferences. Here I'm vague. This could again be approvals, utilities, rankings. Our goal is to decide on a mixture P. These are real numbers between 0 and 1 of the alternatives that sum up to 1. So this is a fancy way of saying this is a probability distribution over alternatives, but I'm not thinking of it as a random thing, but just I have a budget of 1 and I need to split it among different alternatives, and I can do so completely arbitrarily. Each alternative can get an arbitrary fraction of the budget. And this kind of problem has applications. For example, you have a society or a charity, and it has a budget. It needs to decide how to allocate its budget between different projects. Or maybe you have a conference committee that needs to decide how much time in the program to assign to talks and posters and breaks and so on. Or you might have a group and needs to decide what activities to do and how much time to spend in each of them. And a number of rules have been proposed here, and a particularly good rule is to pick the distribution that maximizes Nash welfare. What is Nash welfare? It maximizes the product over all voters of their utility. And what kind of properties does it have? Well, if someone has very low utility, for example, 0, then the overall Nash welfare becomes 0. And so Nash really makes sure that no one has too little welfare. And you can actually prove that it satisfies the core in this continuous setting. And it also satisfies an analogous property to EJR in the discrete setting. And you can think of Nash to be similar to PAV. Why? Well, Nash maximizes this, so it also maximizes the logarithm of this, which is the sum over voters of the logarithm utility. And the logarithm, of course, is essentially the same as the harmonic numbers which make an appearance in the PAV objective. Interesting, if you do approvals, there's also a strategy proof rule that is proportional. This is the conditional utilitarian rule, which is also a very simple rule. It's a little bit like, say, equal shares, where we take this budget, we split it into equal parts between the voters, and then let each voter decide what to do with their money, but they will all decide to give it on the thing that they like, that the most other people also like. So each voter maximizes utilities under the condition that they only use their money for things they like. Okay, that's all I had to say. So this is proportionality in various different settings in social choice. And I hope you found this interesting. Thanks for your attention. I can't hear Nisar. Maybe I'm again the only one.
Yeah, this time I was on mute. Yes. So if anybody has any question, thank you, Piotr and Dominik, for the wonderful tutorial. And if anybody has any questions, we can take a few minutes to ask questions, or alternatively, you can also yeah, and then we can move to the main lobby for contributed posters. If you have any questions, please go up to the carpet where there is a microphone, and you can ask your question. Although a lot of questions have already been asked in chat and responded to by Piotr.
Thanks for that.
Oh, Errol, if you're saying something, then you're muted.
How do I exit this?
Oh yeah, you can click on the top right, and change your view to one of the three views it offers, say the speaker view or the grid view.
Or you press X.
Oh, okay. Can I ask a question?
Yes, please.
So I wanted to ask, it's very interesting how you managed to convince the municipalities to use a new method. I find it very hard, even impossible. So can you...
So Piotr might also want to talk about that. I can talk about... No, I cannot talk about current discussions. But sometimes cities find themselves in ways where proportional method solves some of their problems, in which case that's the easiest. Piotr, do you have something?
What can you elaborate? How does it start? How you just go to phone the mayor and tell them?
Okay, so maybe I can tell a bit about that, because I was involved in discussions with Wieliczka, the city that was used. So basically, it is a very hard process. Wieliczka was one of the cities that we reached out to, but there were many of these cities, and most of them were basically not interested in any kind of collaboration, because basically they consider this as an additional effort. But Wieliczka, actually, we worked with we started working with a political scientist who already had some collaboration with Wieliczka, so that was the first step. So we were able to at least have a meeting with them. And once we have the meeting, basically what we tried to do first was to identify what kind of problems do they have, not starting with presenting the rule. So they said that in Wieliczka it was quite interesting, because they have this phenomenon that people who were submitting the projects actually realized how the rule works, and that the rule does not care about the costs. So what they did was that they were constructing packages of projects. So for instance, they were winning two citywide projects. One was literally was called like that: improving the quality of life in district 1, 2, 3, 4, 5, 6, 7. So that was the project. And the second was improving the quality of life in district 9, 7, 8, or something like that. Right? So basically, it was clear that the people were voting, were playing against the system, and basically because the rule was not proportional, it was favoring this kind of large packages. So what we did is we asked them for data, and once we had the data, then we ran simulations, and we showed them how the results would change. So that was kind of nice to explain to them, and showing on maps which projects would be selected then and which were now, and to showing them some statistics, but the statistics that they would understand. For instance, a kind of statistic that they like is that the number of people who do not have a single project which is selected is low, but also they like to see the really projects, and then they say, yeah, this looks more reasonable from their perspective. And then we started working with them on preparing the law acts and all these things that happened. But we have already, we are quite advanced, and most likely the second city in Poland, the second small city in Poland will use this. And with the second city, it was much easier because basically from the first city, since we used that in Wieliczka, we had a couple of interviews in the national broadcasting station and in the national newspapers. And and then this second city reached out to us and they said, oh, we also have problems with our rules and we would like to try your solution. And then we once again went to them and did the presentation and also told them how did the workshop with people who are proposing the projects and explained the benefits of using the new rule. And they were quite positive from the start, and it was much easier to convince them as the second city, and they will be voting on the law act in exactly 1 week on the next Thursday. But so we will see how this. No, sorry, on the next Friday. Sorry. So in a bit more than 1 week. So we will see how this happens, but it seems that since they already prepared the law act and they are willing to vote on that, so this kind of like very likely that they will adopt that. So it's in general, I must say, very hard process and requires also ideas of how to present the results to non-specialists, so that these results are kind of like understandable to them.
Okay.
Yeah, I could say for me the whole process cost kind of like 1 year of research, basically.
Okay.
And this is not an exaggeration. It was like 1 year without writing a paper and working full time on that with different authorities, like going to them and presenting and thinking how to present, doing simulations and tools to visualize and tools to compute and like lots of these things. So that's really a lot of effort. But now we have the infrastructure. We have also the web page equal shares, and so maybe now it will be easier. And Dominik just said how it was with Arrow. He written in the chat. So with Arrow it was a little bit different.
Yeah, because they already had academic partners they were working with, and then they found out about equal shares themselves and sent us an email. And that's of course wonderful when that happens.
Okay.
Okay, thanks again, everyone. Hope you enjoyed.
Yeah, thank you.